inverter, and we wrote the expression for the delay of the inverter. We wrote the expression for the delay of the inverter as the delay being 0.69 times. We said that on average, if I have a symmetric inverter, then the Rn will be approximately equal to R pull up, and we will set it as R effective. And we said that since Tp هو Tp low to high plus Tp high to low over 2, if this inverter is symmetric, and we will have Tp equal Tp low to high equal Tp high to low. And we said that the delay will be equal to 0.69 times R effective times C self plus C external. And then we said, well, we're gonna take C self outside, so this will be 0.69 R effective times C self into 1 plus C external على C self. Okay. Now, we said that this delay is equal, you refer to it as Tp0 into 1 plus C external over C self. And then we said if I have the 2-to-1 inverter and I want to size it by S, okay, what is going to happen to Tp0? Here it has R effective and C self, and here the Tp0 is going to have R effective. If the transistors are sized S by S, the R will be reduced and the capacitance at the drain node will be increased, and therefore Tp0 will remain the same. Okay. However, the expression for the sized inverter for the delay will be equal to Tp0 into 1 plus C external over SC self, and by S times C self we mean the size 1, we mean the sized one inverter. Okay, يعني أنا إذا بلش Tp0, okay, this C self that correspond to the minimum sized or the times 1 inverter, okay, it will pop up multiplied by S for the delay expression of, pardon me, for the delay expression of this, for the delay expression here, okay, in the S-based inverter. Let me draw it for you. In the S-sized times S inverter. Okay, so لقينا TP for this one, okay, will be equal to this expression with S appearing due to the fact that C self is multiplied by S. Okay, so we said لقينا last time that we are going to size the inverter, and we wanted to see how this is going to affect its internal delay and its external delay. So we looked at this slide and we saw that multiplied by STP0 remains the same. Now let us check what happens if I am sizing the inverter. So let us look at this slide here. Let us look first here at the individual inverter, and so it asks me here in this example, I have a 0.25 micrometer CMOS technology, and I want to compute the low to high and high to low inverter propagation delay and then study the effect of sizing. Okay, so I am given W by L for the NMOS, I'm given W by L for the PMOS. I'm given the value of the external load as function of the output transition. نحن for us typically will assume that they are constant, but here they are being very meticulous. And in order to find the delay, I need first to find the internal pull down Rn and Rp of the inverter. Okay, so referring to the tables, we said that Rn for this technology is equal to 13 kilo ohms. Okay, when my L by W is equal to 1. So automatically what I'm going to do is I'm going to divide 13 kilo ohms by W by L to find the pull down resistance, and the same to find the pull up resistance, but of course I need to use the table value for the P. Okay, now what we do here is we're gonna look at the delay equations for the TP high to low and TP low to high and find the average delay value. Okay, I think I lost connection here. So now we're gonna look at the performance improvement when we are sizing the inverter. Okay, so when we are sizing the inverter, assuming that C self is 3 femtofarads. Sorry, I lost the connection, but bear with me 1 minute. هلا برجع بقى. 1 second. Okay. Yeah, I'm connecting back home. Okay, so let me try to share the screen again. 1 moment. Okay. 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 So yeah, that's popping up. Okay, so now we want to explore the sizing on the effect of sizing on an inverter. And we're given that C load is composed of C self and C external. يعني وضح لي إنه أنا عندي كانت أنا for me 3 femtofarads, okay, for my self capacitance in parallel with 3.16 femtofarad, which is C external. هيدول هن comprising my load. Okay, and now he's asking me to find the delay. So we are going to write the delay as TP equal TP0 into 1 plus C external over SC self. Okay, and TP0 we are going to write it as 0.69 times R. بما أنه هو طلب مني هون ال high to low transition على ال output، يعني ال device which is working هي ال pull down or ال N، لأن ال output is transitioning low. So 0.69 Rn times C self هذه هي TP0 into 1 plus C external على SC self. Okay, طيب great. So let us now look what happens, how the equations are going to evolve. Okay, so okay, I have TP0 as 0.69 Rn times self, so he derived it for me. I can use that automatically, and then I have now we can plug in the equation for TP as 0.69, so 17.94 times 1 plus C external is a 3 femto. So sorry, C external is a 3.16 femto, okay, over S حسب ال S times 3 femtofarad. Okay, so now I can really plot the delay as function of the variable S and see how that is going to affect my performance. Let us look at this plot here. Okay, as S changes, as S increases, we know that the delay is going to drop, but after some S value, some sizing value, I am not going to get the same benefits as the first. يعني أنا إذا كبرت الأس لل5 compared to size 1, I get a significant drop, but from here on the drop is not very significant. So the majority of the improvement is obtained for S equal to 5, okay? And sizing factors larger than 10 will barely result in improvement in the delay. One thing that we need to bear in mind is that I cannot keep sizing my gate anyway infinitely because I am going to load the stage before me. Okay, يعني although my intrinsic delay does not vary لأنه TP0 بتدلها constant والTP حتدلها بتساوي TP0 into 1 plus C external على S C self. Increasing S is going to decrease my TP, بس أنا if this is me and I'm driving the load, but someone else is interfacing me, this someone else is going to be affected by my sizing, his load will be increasing, and also the overall area of the circuit is going to increase. So this is why we care for the optimal delay. Okay, this is why we care for the optimal delay. Okay, great. So let us see now how we size a chain of inverters. But first, let us look at these basic concepts, which are if I have a 2-to-1 inverter with a ratio of 1, يعني minimum size, 1x, then in here, the gate capacitance to this inverter is going to be what? It's going to be إذا هو 2W يعني and 1W دخلوا لي W رجعوا C gate is going to be 2W plus 1W times CG يعني هي 3W CG technology. And the same at the drain here at the output node, C self is going to be CD times 2W plus 1W اللي هي 3W CD. Okay? طيب what if I size it twice يعني هيدا صار 4W 4 to 2 ratio لإله. The capacitance is going to be double. So هي حتصير 6WCG وهي 6WCD. If I size it S times, the capacitance at the gate will be 3W times S and 3W times CG, and the self capacitance will be 3W times S times CD tech. يعني it will be multiplied S times. Okay. طيب so فإذا عندي أنا self capacitance وعندي gate capacitance يعني when I size up the self grows and the gate capacitance also grows. طيب great. So sizing up the inverter reduces its delay but it also increases its input capacitance. يعني أنا the inverter in a chain it has its self capacitance and its gate capacitance. طبعا نحن عم نطلعهم من structure لبرا لحتى نحن نشوفهم. Okay. طيب بس in real life they are an integral part of the circuit. Okay. So لكينا I think okay, again, if we want to look here and see what's the issue with this, so the C self is the intrinsic capacitance of the inverter. It's proportional to the width times CD tech, and the C gate is the input capacitance and it's proportional to the width times CG tech. طبعا مضروبة ب 3S وطبعا هون مضروبة ب 3S. Okay, so let us look at the effect of the fan out delay. Let us see here. طيب. Assuming that I start with a given knowledge, مثلا إذا أنا قلت لكم CG is equal to 2 femtofarad per micrometer and CD is also 2 femtofarad per micrometer. Okay, then يعني CD tech و CG tech, then the relation here is that it is equal to 1 times CG tech. هيدا الكونستانت ممكن يكون 1 ممكن يكون half ممكن يكون 2 so we refer to this as gamma. Okay, هلا we're gonna look little bit differently at the equation for the delay of the inverter. نحن بلشنا إنه TP هي TP0 into 1 plus C external على C self. هلا حنقيم الأس لأنه عم نعتبر السلف هي كلها سوا includes the S. Okay, so let us see what we have here. So TP0 into 1 plus C external على C self, I can write it as TP0 into 1 plus C external over شو فيني أحط محل هاي؟ محل C self. يعني إذا أنا بعرف إنه C self هي مثلا 3W times CD وهيدي هي 3W times CG. Okay, I know that CD is gamma CG. هيدا الإكسبريشن شو بصير؟ 3W ضرب gamma little CG which is equal to what? Gamma into 3W ضرب little CG اللي هي gamma into C big G. Let me erase and let me repeat. Yeah. Okay. So نحن حنبلش من expression that relates CD to what? to gamma CG. طيب نحن لقينا إنه إذا هيدا كان times 1 هيدي هي 3W ضرب CG tech وهيدي هي 3W ضرب CD. Okay. But somebody told me that wait, these are constants and you can really replace this by gamma ضرب CG. Okay, so therefore I can write this as gamma times what? Times 3WCG which is equal هيدي بلشنا 3 omega CD دخلنا relation اللي هون هي gamma times C big G. فإذا C self هو gamma times CG. يعني أنا بالإكسبريشن للديلي I can write it TP0 into 1 plus C external على C self فين اكتبها ك TP0 into 1 plus C external على gamma CG. Great. طيب هلا we're gonna eventually derive for you an expression where you will just be able to automatically size things without having to worry about those derivations. بس it's all to tell you إنه هيدول هن equivalent. So let us see now. Okay, so قلنا إنه TP هي TP0 into 1 plus C external هي TP0 into 1 plus هاي على gamma CG. We are going to define F. Look at this. To me here, what is C external? It is CG2. It is CG for the second or the fan out or the load. Okay, so C external is CG2. So if we define F to be the effective fan out, to be the ratio between the external load capacitance of the inverter and my input gate capacitance. يعني أنا إذا رحت حاولت أعرف إنه F هي ratio قديش هيدا حاطط علي load compared لأنا قديش. ليش هيدول بهموني؟ لأنه هو قديه حاطط علي load is proportional to his size. Okay, this is proportional to his size and my CG is proportional to my sizing or my area. Okay, so لكينا حنعرف الفان out. Okay, we are going to define the fan out. F it's equal to C external على my CG. Okay, لأن الفان out حنصير نستعملها لنقدر نقارن شو السايزنج لإلنا. اوكي ليش؟ لأنه هيدا هو عنده 3WCG ضرب S2 وأنا عندي 3WCG ضرب my own S. اوكي so أنا عندي 3W ضرب CG ضرب my own S. اوكي so let us now just follow the equations and they will guide us to where we want to head. اوكي فاذا نحن بلشنا بالايكويشن تاعت الديلي ان تي بي 0 into 1 plus c external على c self، لابنا منها ان تي بي 0 into 1 plus c external على جاما سي جي، وعرفنا الاف وجينا قلنا لكن اف is c external على c g تي بي can be written as pardon me تي بي 0 اوكي it can be written as TP0 into 1 plus F over gamma. Okay. يعني if you tell me the ratio of C external to my CG and you give me gamma and you give me TP0, I can tell you what is my delay. Okay, so here the equation is very important to remember. So, therefore, if a transistor is sized F times my size, اوكي يعني هيدا حيكون عنده السي جي لإله هي 3W times F times السي جي، وأنا بما إني one time inverter my CG1 is going to be equal to 3W times 1 times little CG. Okay, then I can write the delay as TP0 for my stage into 1 plus F over gamma. اوكي فاذا انا بعرف له هو شو هي سي جي لإله وبعرف شو هي سي جي لإلي and the ratio is going to be F C external is this much to me and I know that it is TP0 into 1 plus C external على gamma ضرب my CG and the ratio is obvious, it's proportional to the sizing لأن نحن ما مدخلين شي تاني معه، أنا بس I'm being loaded by this external transistor. هيدول components are from me and this is really my delay equation. Okay, so the only external capacitance هو CG اللي لإله. Okay, so let us now لكينا look what the slide is telling us. So F is C external over CG. طبعا this is my gate كلها مع transistors لإلها و TP equal TP0 into 1 plus F over gamma. اوكي هلا نحن هون معتبرين انه relation بين سي دي تك وسي جي تك هي سي دي على سي جي هي جاما. اوكي هيدي it is given to us and this is really the derivation that we went from. اوكي here خلص هيدي F على هون جاما ضرب سي جي عم بقلي انه هيدي is F times my capacitance but this is really what matters for us here. Okay طيب now the big question becomes إذا أنا given إنه delay عندي هو if I am given that the delay is TP equal TP0 into 1 plus F over gamma, okay, for any stage. Now, the problem that I am facing here is that I have a certain module or a block that can really interface a small capacitance. And I have really a big long wire that has a large capacitance. And I want to plug in between those two a chain of inverters, maybe one inverter. هيدا الانفرتر عنده CG. Okay, so هيدي CG is small enough that I can accept it for my module. مثلا عاملة ALU وعاملة unit. Okay, now we're going to see what should be the size of, okay, maybe the chain of inverters, okay, maybe the chain of inverters, okay, to allow me to interface properly to a large capacitor without giving a large interface to the previous block. Okay, hello. Let us take the problem one step at a time, and this is the by decreasing man you're asking, isn't it a bit odd that by decreasing C self, which is parasitic, we get a higher delay? لا 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 لحظة بس أقرأ السؤال. One second. We are not decreasing C self. Let me explain to you what we are doing here. One second. So بس let me ask you man one question. Was it clear this equation إنه أنا فيني أكتبها TP0 into 1 plus F over gamma? Okay. Okay, I see your question. You're saying I meant if C self was less. أنا مش عندي هون قصة. أنا عندي I have this thing. I have a circuit block. Okay, and in this circuit, okay, let's close this. Okay, I have a circuit block اللي هي مثلا عندي ALU. Okay, and this ALU is designed with small transistors and it is fixed and nobody can change it anymore and I cannot size it. And the designers told me, go and handle it. I don't care. This is the size, it is fixed, you cannot change it. Okay, and typically I want to target a specific delay for this block. ما هو بالنهاية عندي clock frequency and I need to meet it. I discover when I am building my chip that I have a long wire that has to go somewhere else حسب الoptimization. طيب, this long wire is going to have a large capacitor. وأنا بعرف إذا C external is large, okay, then automatically I'm going to have a large delay. صح? Okay. لأنه what matters is the delay that the capacitance that I interface with for this stage. انتبه, for this stage. So instead of interfacing this fixed block, which I cannot touch as a designer, with the large capacitance, what I do, we put what we call repeaters or buffers. Okay, so بيجي ببلش له أنا chain of inverters. Okay, sorry. I start by putting a chain of inverters, مثلا 4 of them. Okay, such that the first one is small and the others are scaled by some factors S1, S2, S3, so that they are large enough that they do not comprise a large delay when trying to handle the big capacitor. Okay, but what I see as the fixed block, I see the input capacitance as the load. I see as my load the input capacitance to the first small stage. Okay, so كأني I distributed the loading effect of CG onto multiple gates that will be sized somehow in a proportional fashion. One, to minimize the delay of this fixed block which I cannot touch, and to size it optimally such that the chain of inverters can handle the capacitance without too much adding to the overall delay of the circuit. يعني أنا هدفي كمان I'm adding a chain, but I want its benefit I don't want to be hurt by it. I don't want it to overweigh its delay, to overweigh whatever I have gained from interfacing this block with a small capacitor. Okay, so this is the objective that we have here. Now, here he's asking me a very general question. If I have a fixed large load, okay, what should be the best sizing to minimize the delay? And if I have the same fixed large load and I have 2, how can I size this? And if I have 3, how can I size it? But we're starting to introduce the concept and the load is fixed, and that to handle the large capacitor, I really need a large inverter in order to have small delay. Right? We saw إنه بدي كبر الأس أنا. Now, what if I have 2 of them, or if I have 3 of them? Do I really need to have a very big times 10 inverter? Maybe not. Maybe as I'm putting a chain, I can have the size gradually increase to handle this very big capacity. يعني نفترض هيدا 1000 فهمته. Maybe I have to multiply this by 1000. Okay, but now if I have 2 of them, I can make this intermediately large, and then this does not have to be sized as much. And in similar fashion, as I add more inverters in the chain, I can break down the effect by sizing them gradually so that I do not have to size it extremely large. Okay? We added the chain to decrease the delay. Yes, to reduce the effect. اعتبرها كأنها it absorbs the shock of the large capacitor. هلا بنشرح كيف. And it's complex to explain in one empty slide. Okay? To absorb the effect. Yes, man. Go ahead. هلا we will see. Let us do the derivation and then you will understand it. The effect of the capacitor is still there, but the chain will absorb it. Let's see how mathematics will show us. Okay, let us see how the math works. Okay, so we're gonna see how the math is going to work. So, given a super buffer or a chain of inverters of increasing size, okay, given a load that we have here, how many stages are needed to minimize the delay? I'm trying to solve a problem and how to size the inverters. Okay, this is my main concern. كم inverter بدي أحط and how to size each one of these inverters. So let us first assume that we have the chain already. Okay, and let us assume that we know that I want to start with a minimum sized inverter in the beginning. Okay, and then I have to size this times some S times some S times some S. I have to size this. Okay, and I know, so this is given and CG1 is given. If I want to write the delay for an inverter in the middle, okay, we know that we can write the delay for this inverter as TP equals to TP0, اتفقنا TP0 ما بتتغير, into 1 plus what? External load. The external load is coming from the next stage capacitor اللي هو CGJ plus 1 over gamma times my own CGJ, right? مش هو الجيت capacitance للnext stage على my gate capacitance هي C external على CG وعندي gamma below اللي هي مثل ما اتفقنا إنها هي TP0 into 1 plus F over gamma. Okay, بس where F is the ratio of those gate capacitance للnext stage على my gate capacitance. The total delay, how can I write the equation for the total delay? The equation for the total delay is going to be the summation over all the stages from 1 to n of TPI يعني هن TP0 صح into 1 plus CJ J plus 1 على gamma CJ. اتفقنا هيدا هو total delay. Okay, where for the nth stage CG n plus 1 n هي شو؟ يعني n plus 1 هي اللود كاباسيتر صح؟ آخر ستيج اللود كاباسيتر هو الاكسترنال صح؟ طيب great. Let us see now what the math is going to tell me. So let me clear all the markings here and let us see what the slide is going to tell us. Okay, so if we look at the slide here, sorry, pardon me 1 second. Okay, so the goal is to minimize the delay, knowing that CG1 is known, C load is known and fixed. CG1 هستعمل minimum sized inverter. I'm going, of course, to ignore the wire capacitance. So for any input at gate stage J, the gate input capacitance is CGJ, and of course the output self capacitance هو gamma ضربة, والnext stage الextrinsic هو CGJ plus 1. So if I look at this stage, I'm going to find that the delay at stage J is equal to 1 plus CJ plus 1 over gamma ضرب my own CG, which is equal to TP0 into 1 plus FJ over gamma. What is Fj? It is the size of the next stage over my size. Okay, so the total delay when using the chain معلش, excuse the iPad, summation J equal ل1 of TPJ اللي هي TP0 ضرب summation J equal 1 ل n of 1 plus CGJ plus 1 على gamma CGJ وال CGN plus 1 هي السيلو. So طلعنا TP0 لبرا وبقي عندي expression اللي هو 1 plus CJ plus 1 على gamma ضرب CJ. هيك لنشوف كيف I can minimize the delay. So let me insert a new slide and let us see how do we minimize the delay. كيف بنعمل minimizing للdelay؟ شو بدي أعمل هون؟ بدي أخذ derivative with respect to the unknowns. What are the unknowns؟ نحن قلنا إنه TP if I flatten it, it is TP0 into 1 plus our expression هو CG2 على CG1 صح؟ plus هيك 1 plus CG3 على CG جاما، طبعا عندنا جاما هون أوكي، CG3 على جاما ضرب CG2 plus 1 plus CG4 على CG3 until the end صح؟ طيب هلا what are the unknowns that I have here؟ I don't know CG2, I don't know CG3, I don't know CG4, I don't know all the intermediate stages CG لأني ما بعرف sizes. So we can say, well, to know the size is we need to know that del TP by del CG2, for example, should be equal to 0, and del TP by del CG3 is equal to 0, and so on. So I set all of these derivatives to be equal to 0. هيك لنشوف ال CG3 مثلا بأي term مبينة. CG3 appears in 2 terms. The other terms it does not appear and they will drop down to 0 automatically. طيب great, and the ones we don't need them, and the gamma technically I can get rid of it صح, and the derivative of 1 is 0 and the constant will be common so it will go away. So